Welcome to this explainer. If you're working toward mastering ISO IEC 4201-2023, you already know that artificial intelligence brings a level of complexity we've literally never seen before. Today, we're supercharging your auditing toolkit. We're officially transitioning away from subjective guesswork and diving headfirst into hard, data-driven AI risk analysis, exploring exactly how to measure that complexity with absolute precision. So, let's kick things off with a pretty provocative question. When you're dealing with the massive, interconnected complexity of AI, is a qualitative gut feeling really enough to protect your organization? Historically, sure, auditors could sometimes rely on expert judgment to estimate risks. But today, with AI systems operating autonomously and processing millions of data points every single second, a gut feeling isn't a defense anymore. It's a massive liability. Here's our roadmap for today. We'll cover the shift to quantitative risk, advanced risk modeling techniques, the 4 pillars of data quality, and visualizing risk for decision makers. Let's jump in.
Starting right off with Section 1, the shift to quantitative risk. There is a stark contrast happening here. It's basically the difference between navigating by a vague gut feeling versus using a highly precise mathematical GPS. Qualitative analysis, things like descriptive insights, employee interviews, or basic SWOT analyses, it's definitely useful, but it just entirely lacks measurable precision. Quantitative analysis, on the other hand, that uses hard numerical data, statistical calculations, and real historical metrics to generate concrete risk profiles. When you're auditing AI systems that dictate financial trading or even autonomous driving, you absolutely need the statistical certainty of that GPS.
Moving on to Section 2. Advanced risk modeling techniques. Let's open up our analytical toolkit. First up, we have statistical simulations, specifically Monte Carlo simulations. These are fantastic because they allow you to mathematically predict the probability of, say, a security breach by modeling thousands of historical scenarios. Instead of just guessing the likelihood of a cyber attack on an AI model, a Monte Carlo simulation takes historical threat data and runs a massive number of simulated outcomes. It calculates exactly what might happen and what the financial impact could be, giving you a mathematically sound prediction. No wild guesses required. Next up, we have machine learning risk scoring models. These algorithms brilliantly assign dynamic, automated risk scores to complex AI systems, like those autonomous vehicles we mentioned, which triggers immediate scrutiny the second it's needed. Think about it. If an AI model suddenly starts processing double its normal volume of sensitive data, its risk profile changes instantly, right? These machine learning models continuously evaluate features like data exposure and system complexity to update the risk score in real time. That means you are never auditing based on yesterday's reality.
And our third tool is predictive analytics. This essentially acts as your crystal ball to forecast risks, things like algorithmic drift, before they even happen. By training a predictive model on historical AI failures, an organization can detect really subtle emerging patterns. For example, if a medical diagnostic AI starts showing a slight statistical drift, predictive analytics flags that vulnerability immediately. You can step in and mitigate it way before it cascades into a critical system failure or a major compliance violation.
Which brings us to Section 3, the 4 pillars of data quality. Now here's the catch. All those shiny advanced tools we just talked about, they are absolutely useless if the foundation is cracked. Without pristine data, your advanced algorithms are just going to confidently give you the wrong answers. As a lead auditor, you have to strictly enforce the 4 pillars of data quality: accuracy, completeness, consistency, and timeliness. Use it as your ultimate checklist to ensure analytical results are actually valid. Accuracy means that data reflects reality, because inaccurate user access logs will just hide unauthorized breaches. Completeness ensures you have the whole picture. If an AI risk assessment only looks at internal threats and ignores external vendor risks, it's totally incomplete. Consistency means you're measuring the exact same way over time, otherwise safety trends get completely skewed. And finally, timeliness ensures your data is fresh and up to date. If even one of these pillars falls, let's say your data just isn't timely, you're flying blind. You end up making crucial decisions based on outdated threats, which jeopardizes the entire ISMS system. It's the classic rule: garbage in, garbage out. The ISO standard explicitly demands evidence-based decision-making. So, if management is making decisions to accept, mitigate, or transfer AI risks based on outdated vulnerability data, they are quite literally leaving the front door wide open to modern adversaries. Let's head into our final part, Section 4, Visualizing Risk for Decision Makers. Okay, imagine assigning a likelihood of 8 and an impact of 9 to a potential data breach. Suddenly, you can present management with a stark, undeniable quantitative risk score of 72 out of 100. This is the true power of quantitative analysis. When you walk into a boardroom and just say, hey, we have a high risk of a data breach, it is so easy for executives to nod their heads and just move on. But when you walk in and say, our empirical risk score for this AI model is 72 out of 100, which completely crosses our maximum threshold of 50, well, you demand immediate action.
Or think about tracking KPIs. ISO IEC 42001 requires organizations to establish clear metrics to measure control effectiveness. So if your internal policy dictates an 8-hour response time to an AI system failure, but the hard data proves it's actually taking 12 hours, presenting that stark contrast instantly highlights a critical nonconformity. It's clear, it's undeniable, and it requires a corrective action plan right then and there.
The absolutely crucial takeaway here is that data storytelling physicalizes invisible risks. Say 95% of an AI's training data is perfectly safe and properly encrypted. Awesome. But that remaining 5% that is unencrypted and vulnerable, that represents a massive regulatory and security liability. When you audit control effectiveness and frame the data this way, it leaves no room for debate. Visualizing the facts makes the problem impossible for management to ignore.
You can then consolidate all of these quantitative findings to build something like a risk heat map. By objectively plotting the meticulously calculated likelihood against the impact severity, you create a visual matrix for stakeholders. That red zone in the top right corner, it screams for attention. It takes incredibly complex, multi-layered algorithmic risks and instantly turns them into a simple, undeniable directive for where to allocate resources.
This quote from the Standard perfectly summarizes exactly why this all matters. Objective data is the absolute gold standard for driving evidence-based decisions in your audit. It removes the guesswork. It entirely removes the bias. It replaces human assumption with statistical certainty, ensuring that your AI systems aren't just cutting-edge and innovative, but deeply secure, compliant, and trustworthy.
To wrap up this explainer, I'll leave you with this final, critical thought to evaluate your own audit readiness. Go take a look at your current risk registers. If you're still seeing words like high, medium, and low, without the robust mathematical models, statistical simulations, and strict data quality pillars backing them up, well, it's definitely time to upgrade your approach. Thanks so much for joining me today, and I challenge you to start quantifying your risks right now.